Okay, so my name is Scott Keating. I'm a senior product designer at SideFX Software, and I'm extremely happy to reveal Solaris here at SIGGRAPH. And let's just jump right in. We've got a lot of stuff to cover, so we're just going to dive right in. So the first thing we want to talk about is, what is Solaris? And Solaris is a new context in Houdini, specifically designed around the tasks of lighting, lookdev, layout, and rendering. And a key point is that it is USD-based. And when we say USD-based, we don't mean that we just will import USD. We mean that we work directly on USD. So USD, which is Universal Scene Description for those who aren't aware, but it's we work natively with it. So Solaris nodes, or LOP nodes, work directly on USD. It edits the data directly. You're creating actual USD as you put down these nodes. And if we're going to do that, we're going to edit this USD and create it and manage it. We also want a way of rendering it directly as well. So we're also going to demo a little bit of Karma, which is our new CPU-based renderer, which is directly connected with Hydra. It is a Hydra render delegate, which means it can run sort of live in the viewport, taking in the USD as you're generating it. So again, let's just dive right in. It's a lot cooler to just show you things than it is to describe it in the abstract. So the first thing I want to show, because we're going to sort of skip over a lot of important details just to show you a lot of features, is when I talk about a scene graph or a scene graph tree, what I'm really talking about is essentially this hierarchy you see in this sort of new custom interface that we have inside of LOPS or Solaris. There's a lot of functionality here we're not going to talk about today. But basically what this is, what the scene graph tree is kind of a visual representation of what the underlying USD scene is. So it's the hierarchy you're building. The transforms, the meshes, the lights, the cameras, the materials, everything that you can embed in USD or describe with USD, you can sort of visualize here in our scene graph tree. And like I said, there's lots of functionality here for hiding things, representing things in a lightweight manner, payloads, if you're familiar with that terminology. But for the moment, when I talk about scene graph trees or hierarchy or primitives, I'm basically talking about elements in this UI. So we're going to start out with lookdev. In some ways, these terms are a bit nebulous because the reality is they sort of blur between different departments. There's not a clear line for look development necessarily. But this would be a task like you want to import some sort of an asset, assign a material, and then maybe export it in some useful way. So let's take a look at a very simple example of how we might do that in Solaris. So first of all, everything is in one place. So I can bring in geometry. Again, USD directly. You'll see I'm loading a USD file. Just this very simple asset here. And let's throw down some lights. So right away, we have this new world where lights, geometry, editing of geometry, assignments of materials all happen in one place. So I'm just connecting up some lights and moving them around in the viewport. And now I'm going to set up something called a material library. And the nice thing about this workflow is that nothing is sort of new here. You've always been able to do these types of things in Houdini. But having this single context means everything is a lot more explicit. So you used to have to sort of chase down parameters, jump between different contexts. And here now everything lives in one place. So we're just building an extremely simple shader here. It's just some noise, and that's basically it. We're just going to attach that to our geometry. And now we're just going to switch our viewport from OpenGL to our new Karma renderer. And you'll see that it immediately updates and begins rendering live in the viewport. And right away, this is super useful because, again, it makes everything happen in one place. Right? You're not jumping back and forth between different viewports. As I change my shader settings, things update immediately in the viewport. So if you're doing this type of look development, even in this very simple case, getting this fast feedback and this interactive feedback obviously makes your workflow a lot smoother and a lot nicer. So we've put a lot of work into, obviously we want to make Karma very fast and very able to handle lots of geometry, but we also want to make sure it updates quickly so that when you're changing things like displacement amounts, for instance, you immediately get the results. You can zoom in, tumble around, see how the light changes on your object. Here you can see we just adjust the displacement and we immediately get the result in the viewport. And the beauty of USD is that everything we've done here now can actually be encapsulated by USD. So rather than having to manage materials and geometry and lights and cameras all separately, they can all essentially live together in one USD file. And that means you can set up a scene like this, write out a file to disk, and everything comes along for the ride. And then you might think like, oh, but isn't that creating a lot of overhead? Like I don't want the lights when I load this asset. But USD has a very powerful layering system that we'll talk about a little later. That means that you can just disable or enable or ignore parts of the USD file, right? You don't have to work with everything that it has. You can mute it, prune it out, and so on. So something else that USD enables, and something that happens in production pretty frequently, is that you may actually have more than one render target, right? So let's say you have Karma, and you've set up a material for Karma. And again, we're going to use the same asset and essentially the same network with a bit of a simpler shader on it, just this sort of red, noisy shader. But suppose you actually wanted to render this with RenderMan instead. So RenderMan is a Hydra render delegate, so it shows up in the viewport. But you can see the material goes away, right? Because RenderMan doesn't know what to do with a Karma shader. So let's go ahead and just build a sort of equivalent RenderMan shader to the simple sort of red, noisy object we created earlier. And again, we're just going to drop down these nodes, assign the RenderMan material, and obviously it shows up in RenderMan. But now the problem is, of course, if I switch back to Karma, I've lost my Karma material. So something that's really awesome with USD is that you can actually have multiple materials assigned to a single USD primitive. And the Hydra will basically ask for the correct material when it attempts to render for a specific render engine. So using that collect VOP, we can actually now just switch between Karma and RenderMan, and we'll automatically switch to the correct material for that renderer. So this suddenly frees you up, again, to always work in the same place and just build everything that you need in one space. We're also just going to show here at the end a USD preview surface, which is basically a shader that's supposed to be common across all render delegates. And it can't replicate the noise, but we can just set it to the same color at least. So you get an OpenGL representation, a RenderMan representation, and a Karma representation of essentially the same material with whatever variances there are between the different shaders due to differences in noise and so on. Since we mentioned RenderMan, we also have some other render delegates that are in process from the folks at Redshift and V-Ray as well. So the number of things you can target in the viewport will sort of expand over time. So another really awesome concept that USD has is its idea of a variant. And a variant is essentially a primitive, again, meaning like a point in your scene graph, that can hold multiple versions of something, variants. And they're usually connected in some way, right? So in this case, we have these books, just these 5 different books. And we can take those and sort of embed them in a variant. And what a variant will allow you to do is then set what you're going to see when you look at that primitive. So in this case, we, again, just target that same variant that we created and go ahead and change our variant to each one of the books. And this is a really interesting concept because it allows an asset to become more than just a thing unto itself. It becomes almost a concept, like books go in this asset, or trees go in this asset, and a tree can be any number of other things. Here we can actually look directly at the USD that's generated by right-clicking on the node and going into our debugging tools. And so here we're actually generating, you see references to files on disk for the different books, and we're just appending those references in the USD file. Right, so this is, again, very lightweight representation. Everything is being referenced from disk, so you're not creating these massive files. Everything is being pulled in just sort of on demand, essentially. And earlier I mentioned the idea of a layer in USD. So let's take a look at a variant layer instead. So rather than swapping out full pieces of geometry, what we can actually do is just say, well, I just want to change some properties about this thing. So we'll start off with something simple. We'll just make a blue book, and we'll go ahead and make a red book, except we'll also add a transform to our red book. So we'll just tilt it on its side. And so what this means is that rather than having, again, 3 different books, 3 different assets on disk somewhere, we have a single book, and then we just layer on these changes as we change the variants. So rather than having to store a red book, a blue book, and so on, We just store the differences between these layers. And then we compose them together when we ask for a specific variant. So again, if we look at the actual USD, you can see that in the blue and in the red variant, we have no reference to the geometry at all. It's just saying, this is the color when I'm set to this variant. This is the transform when I'm set to the red variant. And so again, you're taking the minimal set of changes and applying those. So the idea is to keep things nice and fast and efficient, but also very flexible. And even though we're not showing it here, a variant can be almost anything. It can change your entire scene graph. It could be 3 entirely different scene graphs. It does not have to be simple changes. It could be vast, sweeping changes. And that enables you to have interesting tools that you can build then using these variants. So this is just an asset that creates variants for different levels of detail, for instance. So we're just going to take this barrel, and we're going to say, I want 3 levels of detail. You know, one that's 100%, one that's 20-something%, and then a really low percentage. And you can see in the viewport how it updates. Underneath, inside this asset, we're actually using SOPs to do this. So LOP networks can communicate directly with SOP networks. And you can see now we can switch between those LOD levels. So again, the asset itself now has this concept of like how I can be represented in these different contexts. And then we can tie that into sort of a larger tool set where we can say now, okay, well, when the camera is a certain distance away from this asset, let's automatically set the variant to a lower level of detail. So we're just going to set up these 3 sort of distances from a camera. And you'll see that when we play this little animation now, as the barrel moves away, or I should say the camera moves away from the barrel, it doesn't really look like it changes much in the viewport, but you can see in the bottom the different variants being switched between the different levels of LOD. And this is just an example. Again, this could be any number of things. You could be changing render settings, for instance, not LOD. You could be swapping out different shaders. Maybe you have a lower quality shader that's a baked version of a very high quality shader, for instance. The point is the variants encapsulate something about the asset, hopefully in a way that makes sense, like levels of detail, related other assets, like types of books, for instance. And so here's like a larger network now where we're taking all the concepts that I just described and putting together these books along with their materials, along with some other variations, and putting them all together in a single file. And layers are used not just to layer things on top of each other, but also to define what actually gets written out to disk when you write out a USD file. So these little arrows are just indicating where we're actually automatically generating files on disk as well. And you have full control over that using various configure LOPS to do it. And if you're going to have this idea of layering and all these sort of tools to create layers and so on, you also want ways to inspect those layers. So we have a tool for opening up all the layers in your scene. It tells you exactly what layers exist, which ones will be written to disk, and what their files will be when they are written to disk, as well as which layers will be discarded. Because sometimes you're basically working in a temporary layer while you're working in LOPS. So it's really important to know, what's going to stay, what's going to get erased, what's going to get written to disk. So we're trying to make this suite of artist-friendly tools, but also make sure that behind it there's these really nice debugging tools, right? Because this is going to sort of spread through your pipeline, and obviously, if you're going to have a pipeline based on USD, you want tools to interrogate the files that are being generated. Okay, but so what about the case where you have a more generic material and you want to apply it to a bunch of stuff, right? So there's not one asset with one texture map. There's a bunch of stuff, and you want to apply something like just a color, for instance. So we're using this node called Vary Material Assignment here to target these pig heads, and we're just picking from one of our red, blue, or green materials. We also have a spatial distribution in this node. So you can clump materials together. So this is really useful for things like forests or crowds, places where like maybe certain types of things tend to congregate together. And obviously you can add different offsets to these to make them look a little more varied. And also a weighted random. So this is a really nice one where you can say, I want 10% blue, I want 30% green, I want 80% red, something like that. So you can have a lot of control over this randomness while still getting a nice amount of variation. And that's great. And this is, again, a very high-level tool. It's the idea you put down this one node, gives you a nice suite of functionality. You you apply it, it's good to go. And obviously, there could be many more materials than just these three colors. But what about when you want to take this a bit further and you actually want to say, like, well, I need to customize this distribution. I don't want to just use this one that you gave us. We need to be able to customize this a lot more. So we also have this material assignment node, which allows you to do sort of more directly controlled versions of what I just described. So again, we'll just use our new sort of primitive targeting syntax here to get all of the pigs. And we'll start out by just assigning the blue shader to all of the pigs. So right away, that's very direct. But now I want to say, you know what, I don't want to just have a direct assignment. I want to have some control over how that's being assigned. So inside this node is a VOP network. And what this VOP network can essentially do is say, like, okay, construct a rule for how we assign these shaders. So just in this example, we're just going to use a string. So something very, very simple. It's just a path to the material, in this case the blue, and then we'll follow it up with the red and the green. And we'll just do something very simple, which is use a modulus on the element number. So for every pig gets a number, essentially. And we'll just export that as the material to assign. And what this allows us to do now is that back up at the top of our asset, we can say, okay, let's use that instead of assigning it directly. We'll just pick it from our chooser here. And you see everything turns blue because we've chosen the blue for all objects. But if we change our divisor here, you can see now we can get this sort of stripy pattern, a checkerboard pattern, and so on. Now this is a very simple example, obviously. This is probably not practical in most cases. But the point is that you can do it. You can build any sort of logic in there that you would like. So once we have these materials assigned, that's great, but obviously all of the green ones, all the blue ones, all the red ones, they still all look the same. So you want to also have control over the parameters of those materials. And this node also allows you to override that using a VOP network as well. So we'll just assign another shader. We'll call this parameter variation. And again, we'll just do something very sort of simple here, where we take each pig and we just create a random value for each one. And then we feed that into a ramp so that we, instead of picking completely random colors, we're basically choosing randomly from this set of potential colors. Again, we'll just go ahead and assign it. And now you can see we get random colors chosen from that ramp. And this is actually overriding that material, right? So it still has the red, the blue, and the green material assigned, except we're overriding the base color channel or parameter with these new values. And just to show that it's not just the color, obviously, we also can, for instance, override the metallic amount, the metallicity parameter. And you can see now we get a lot of variation from a couple of just very simple networks. And of course, because these are VOP networks, that means they can be wrapped up in assets. And so, a shading TD or somebody can take an asset like this, wrap it up into something that just presents the ramp, for instance, to the artist. And they can work very quickly like this. They don't have to go in and play with each individual VOP node. So that's great. That's one way of doing it. What about like on a massive, massive scale? Like instancing, for instance. And there's a couple of types of instancing in USD. And in this example, we're using a point instancing. And so basically what we want to do, we're going to use this thing called the stage manager. And we're going to come back to that a little later, so don't worry too much about exactly what the stage manager is. But it's just a way of pulling a bunch of stuff from disk and putting it into a folder, essentially. So we're just going to bring in this library of stuff. And then I'm going to use that as a target for our point instancer, essentially like a library of things to use with our point instancing. And we're just going to grab our library from the second input. And basically what this does now is it uses whatever points are inside this add point instancer node, and it puts assets on it. So in this case, there's only one point inside by default, and you can see that we can go ahead and go through the different variants just by changing the seed. But that's obviously not that good in practice. It's just a default to make sure something happens. But inside there is a SOP network. That's directly inside. So we just scattered some points, pretty typical Houdini operation. And now every point gets a different version of our asset library. So we'll just now throw down some lights just so things are a little bit clearer here so you can see it a bit better. We'll just increase the intensity so you can see all of our assets. And And now let's go back inside and make this something a bit more interesting. Because if you're going to instance something, you don't want to do it 5 times. You want to do it a lot of times. So let's just put down an attribute randomize node to influence these instances. And in this case, we're going to just change their orientation randomly, essentially. And while we're at it, we'll go ahead and turn up the number of instances to like 100,000. And we'll also make the grid much larger so that they're not all just sitting on top of each other. And now you can see here we are in OpenGL with 100,000 of these instance objects. And as I zoom in, we're calling out the primitives to keep the interaction nice and fast. But if we switch over to Karma, we get the full amount of instances all live in the viewport. And again, this is the real value of having this Hydra delegate, is that everything stays live and interactive, right? You can have all of these instances, you can have all this stuff interactively in the viewport. So if you're trying to figure out, like, well, does this look good, you can get the real results. So it's basically a trade-off between, performance. If you want pure performance, maybe you go to OpenGL. If you want to get a full look at your scene, you go to Karma and you render it. And because we're trying to get a nice, fast render in cases like this, you can get really good feedback about exactly what's happening in your scene. And we're sort of starting to blur the lines here. I mean, this is theoretically still look development, but at the same time, we're almost starting to get into layout to a certain degree at this point. So let's look at a slightly more practical example of instancing that might be more akin to a layout sort of task. So here again, we've just brought in a library of things. In this case, these sort of little jars with plants and things in it. And we also have this bookshelf. We're just going to use a duplicate LOP to create multiple versions of it. And then we're going to use that as the target for our instance points. And what's really interesting is that, again, now I can use a LOP import, pull that in, and start working in what's pretty much just standard Houdini operations. This doesn't really have anything to do with Solaris, but it shows that we're revealing all of the tools, the very powerful procedural tools that are in Houdini that have been around for a long time, and putting them into a whole new group of artists' hands, right? So in this case, we've just isolated the tops of these shelves. Again, we're doing some playing around with attributes, but you can see we've just decorated the shelves with random versions of our instance library. We'll just tweak some of the points a little bit and get back to the results, and then, as before, jump into Karma to actually see the full render. And again, because the input to this scene are these USD assets, they have all the materials and so on applied already, right? So again, it's not a matter of importing, setting materials. Everything comes through the USD files. The USD primitives have all that information in them. But you can see here that, we only really have like 7 objects or something. There's not that many different things. So, the green tall jars sort of stick out and the blue short ones stick out because it's like, oh, I can pick out that they're basically all the same. So let's add some material variation now on top of that. And again, there's some high-level nodes and some deep nodes for doing that. We're going to show one called instance variation. And this has a very simple interface where, again, you target those instances. You say, like, I want to affect the parameters of this group of instances. I'm going to override the base color, which in this case is just sort of the diffuse color, you might say. And just to start, we'll just make them all red, right? And again, the really nice idea that Hydra pulls the USD changes and pushes them right into the render immediately. And then you can actually write Vex code directly in here. You don't even have to go into a VOP network. If you know how to write Vex, no problem. You write one little line of code. It randomizes the colors on each of the jars. Or if you want to replicate what we did in VOPs, we just extend this a little bit with a ramp function. And we'll have basically the exact same tool we had previously, except here at this top level now. And like I said, as with everything else, all of these could be made into assets themselves, right? So somebody could just drop down this node and play around with the specific parameter set that's useful to the artist who's using it. So since we're sort of bridging that gap, let's talk about some of the layout tools in LOPS. So here again is this stage manager, and this is like a highly sped up video, but the stage manager is basically a way of constructing a scene graph tree in a much simpler way than using multiple nodes and layering things in. This is meant to be a very direct way of grabbing files from disk, putting them into your scene, manipulating them with standard sort of almost modeling style tools, placing them in your scene rapidly. The idea here is that an artist who is building a scene like this really shouldn't have to think about the repercussions of what they're doing. You want to have something very simple, very high level, where you can set variants, move things around, snap them to surfaces, and so on. And so we've just taken all that functionality and wrapped it up in sort of a custom state, as well as this custom UI that you see in the top right here. But pretty quickly, you can put together a scene like the one we've been showing. You can see you can import the assets, including the instances, throw down some lights, and then jump into Karma to see it with all the lights and shadows. And this is a nice sort of fast way to construct a scene with minimal numbers of nodes and still get a nice result that you can pass downstream to other people in the pipeline. And we're developing lots of tools like this, like artist-friendly tools for doing specifically layout tasks. So one of the ones we're going to sort of show here is this idea of introducing sort of physical editing into layout. So let's say we've got these books, and a pretty typical task is to stack them up on a table, for instance. So I can drag this book down with a handle, and now I can just push it against the other book, and you'll see that it sort of gets modified using Houdini's sort of underlying physics tools to do that. So the idea is to try and make this, instead of a task where you're moving pivots around and trying to align things, it becomes like, well, let's treat it like the real world. If I want to make a stack of books, I just place them and push them against each other. And so we're trying to expand the tool set into this realm of almost physical reality, where if you want to do some set dressing, you sort of can just say, I'm going to push these books together. Maybe I'm going to run a quick physics sim and just drop a bunch of stuff into a bucket, for instance. And we want to expand this tool set over time. So this is kind of just a preview of where we're going. But I think there's some really interesting possibilities with this that'll make layout a lot easier. And then again, this layout happens in isolation to a certain degree. But the reality is other departments are pulling from layout, and they're sort of feeding layout as well. And effects is sort of a key one of these departments where they are technically separate from layout, but at the same time, they have to interact with each other. So something that's really awesome about this layering system that I mentioned earlier is how it actually enables artists to work together on files all at once using the same tools. So imagine a template like this. So at the very top, you're pulling in something from a department. So in this case, we're pulling in the layout department, essentially the scene that we just built. So at the very top of this network, it's saying, go get me whatever the latest version of the layout of this scene is. And you can see we've broken it up into these two sections, this sort of purple section, this gray section. And in the purple section, we're going to do whatever overrides you as an effects artist need to do to that scene to get down to the geometry that you want. So in this case, we're going to prune out a couple of things, because we're going to add a little volumetric effect. So we'll use a prune node, and we'll just say, you know what, I just want this table and this pot. And then I'm just going to invert that. And I've just thrown away everything else in the scene, basically, because I don't need it. But because that's happening above the effects layer, none of those changes will ever make it into the effects layer. So the layout is completely unchanged. On disk, it's fine. It's a completely non-destructive workflow. The effects artist now works in his own layer. Even though he's pulling in all of the data from the layout layer, he can safely delete things, move things around, prune out objects, bring things into SOPs, for instance, and cooking show style, we're going to just jump ahead to the simulation being finished, because this is just standard Houdini simulation stuff. We're just in Houdini as normal. You can see our little smoke sim. We're just going to write that out to disk. And now in our effects layer, we're going to use a volume LOP to pull in that data off disk and assign a material to it. And place it somewhere in our hierarchy that makes sense. Now, the nice thing is that we can place that directly into the hierarchy that layout has constructed. So this volume now shares the same transform as the cauldron does. So we can actually put it directly into the layout's structure. which is really, really interesting, because that means when we put these two layers together, it goes into the logical place. It's automatically assembled into the right part. These layers sit on top of each other and can override each other. So you can see now, we can jump down to our little preview node here at the bottom, and that shows us the full scene plus our effect. Right? But let's say that as an effects artist, we know that, like, well, actually, I want to add a light to this. There's an effects-specific light, and this light is just going to sit inside that cauldron. We're just going to sort of light that smoke from below. And so the effects artist is adding their own light, and this can be because they know they need it, or maybe it's a suggestion to lighters downstream that, like, oh, we should put a light here. So again, we've just added in a light. We've placed it into our lights folder, again, in the same hierarchy as our layout department. Just for this example, we're also going to just prune out all the other lights in the scene. But again, because that's happening in this first layer, the effects layer is totally unaffected, as is the layout layer. And so now we've got a light in our scene for just the effects layer. We can use this switch node to switch back and forth to preview it. Well, what does it look like in the full scene? What does it look like purely with the effects layer? And suddenly, this is a really empowering way of working, because it means effects artists and layout artists, animators, character artists, anybody in their department shares the exact same tool set. Right? So you're no longer saying, like, okay, I'm going to work in isolation here, and someone down the line is going to have to pull this in and place it all into the correct place. Instead, everybody is working on the same hierarchy, the exact same scene. And because you can work in these layers, you'll never accidentally break something in somebody else's scene. It's a completely non-destructive workflow. And just because we were talking about volumes, I do want to talk a little bit about the volumes rendering in Karma. And you can see this is a much more high-resolution volume than the one we were just working with. But everything still stays nice and fast and interactive. You can move the camera around. You get nice feedback. In cases where rendering is a bit slow, which will be the case with a high-resolution volume like this, we can, of course, enable the optics denoiser directly in the viewport as well. And you'll see that as the camera comes to rest, we start denoising this volume. Again, so you can get really fast feedback at whatever layer of detail that you need. The denoiser tends to smooth things out a bit too much, but it's really good for evaluating lighting. OpenGL is very fast, but obviously it's not going to match exactly your final render. So we're just trying to give you as many ways as possible to set up the scene as quickly as you can at as high a quality as possible. But let's go back now to a different effect. Okay, so again, we're using that exact same template, but we're going to do a very different style of effect here. We're going to create a rigid body simulation on those shelves that are in the background. And earlier you saw we set those up as instancing, right? So all those pots and things, those are instances. And as you know from instancing, it's a render time effect, right? Like instancing doesn't have objects there. It only pulls them in as is necessary. So we have a tool set that allows us to look at these render time objects and say, actually, I need those as real objects. So we can use the instance extract node. And what it'll do is it'll target those instances, find out what the root of them is, what prototypes are used for the instancing, and now pull them out into real, actual objects. And on top of that, it actually hides the actual render instances on this effects layer. So again, when we bring in this layer, we'll automatically hide those instances and replace them with our rigid body objects. Again, this non-destructive workflow is so powerful for doing this kind of layering. And what Houdini's LOPS brings to the table is the proceduralism on top of that, right? So USD has the non-destructive layering, and LOPS allows you to have tools to procedurally manipulate those non-destructive edits. So in here, we've just done essentially a similar setup to our previous simulation, except it's a rigid body simulation instead. We just knock over the shelves. And we've done this using something called a SOP modify LOP. And that's a really interesting node, because what it does is it looks at essentially what the input is, in this case, the original shelves, and what the output is, which is really just new positions and transformations, right? You don't need new geometry. So if we actually go and look at what the output is, you can see that there's this thing called an over. And all it's doing is changing the transformation on those objects. So this effects layer, this rigid body effects layer, is not a sequence of geometry at all. It's purely a bunch of transformations. So it's very lightweight. and it just sits on top of the transforms that were coming in from the layout department. So again, this idea that you can work all in the same place, everybody has access to everybody else's stuff, and you just apply just the changes that you made. That's it. That's all you have to change. And you can see here as an example, we have our effects layer, and as soon as we add our layout layer, and as soon as we add our effects layer, it immediately replaces the correct things in the hierarchy with the new effects layer. And you can see also how nicely it plays back because you're just, again, changing these transforms. So a really nice set of tools to do this. And now this is just effects that we're showing here because Houdini's kind of known for effects. But this works for every department. It really doesn't matter what it is. You work on your own layer, and at scene assembly time, you bring in each department's layers, lay them on top of each other. Everything is composed together to get the final result that you would expect. So that makes it really a nice sort of smooth transition from layout and effects into lighting. And I'm kind of using lighting here as a catch-all almost for the final stage of your pipeline where it's scene assembly, final lighting, you're doing actual shot work essentially. And so let's take a look at actually just lighting this scene now. So again, we're just pulling in the layout. I've pruned out the original lights that were in the scene that the layout artist had put there as a suggestion, and now we're just going to throw down a bunch of lights. And we do this by just creating nodes in our network that represent the lights, and we move them around in pretty typical way you would expect. The nice thing about the Karma implementation that we've done in the viewport is that the OpenGL handles sit on top of the render, but actually correctly in space. So you can be rendering live while still having access to your OpenGL handles. So you don't have to switch back and forth. You can move the handles around. You can interactively see exactly what kind of shadows, exactly how the materials are reacting in this scene. So we're just going to place a couple of lights. But you can probably imagine already, there's only 7 lights or something in this scene, that it would probably get annoying to jump back and forth between these nodes to change any values that you might need to change. So we've also created something called the light mixer. And it is a LOP, it's a node, but it has this custom interface that you see here on the right now. And this gives you a high-level view of all the lights in your scene, and a specialized interface specifically for doing lighting tasks. So as an example, we're going to go ahead and say, let's take all of our tent lights, all of the lights inside the tent, and let's make a collection out of those. So we'll just call those tent lights, and that automatically populates our mixer now with a nice set of very artist-friendly controls with a master slider, which controls all of the lights in the collection, so we can turn off all of the lights, as well as individual sliders for each of the lights in that collection. And again, the nice interactive updating in the viewport. Now let's go ahead and make another collection out of these fill lights, these sort of cool lights that we set off to the side to fill out the scene. We'll create a collection for those as well. And now we can collapse our first collection and keep the master slider visible. And then we can, for instance, solo this new collection now. So we've turned off all other lights in the scene except for this one. We've also enabled the denoiser again because you're really just evaluating the lighting at this point. So the faster you get to a nice clean result, the easier it is to work. Obviously, you can set things like the color of the lights individually. You can set those. So really what this is almost like a mixing board, right? Like we've set up a set of controls for the artist to use at a very high level so they no longer have to even think about the network. They don't have to worry about that at all. This is actually under the hood setting parameters on a node. But presented to the artist is this high-level set of controls. The other nice thing about the master slider is that we can also use it to tint all the other lights in the collection. So if you want to say, oh, this looks great, but I wish this was like a little bit warmer, a little bit cooler, you can use this master controller to tint all of the lights in that collection. So again, just trying to take very typical sort of lighting tasks and expose them with a nice, clean, simple UI. And in the case where you have way more lights, hundreds of lights, we also have this sheet view of the same setup. So here you see all of your lights, all the properties of the lights in a more sort of digestible format when you have to deal with large numbers of lights. So it's essentially 2 views on the same data. And so just to end up this example, we'll just change the sort of evening moonlight into something more like maybe a sunset-y sort of color. So the idea here, again, give the artist the tools they need for the task they need, but keep them in the same environment as every other artist working on this scene. Excuse me. So how does this work if you have multiple setups? So here was just a single setup, right? We just created lights for this scene. So let's take a look at what a multi-shot setup might look like in LOPS. So essentially, at the top, we bring in all of the sequence level tasks, like again, layout, effects, lighting, animation. And now if you're working on a shot, you just say, okay, I'm working on shot 1. I'll create a camera, I'll create some lights, I'll use my light mixer to set the values, and then I'll continue on to shot 2, where I bring in my rigidbody effects, for instance. Maybe it's a little later in the evening, so I set up some different lights for that. We move on to shot 3, where now I bring in that effects layer with the volumes, and you see the volume light has come along. We set up some more lights here to light this scene for sort of an evening shot with this sort of eerie light underneath. And for shot 4, we say, you know what, let's pull in both the rigidbody effects and the volumetric effects from shot 2 and 3, but the lighting from shot 1. Right? So these shots now, they can talk to each other, right? They don't live in isolation. And we can use a switch node at the bottom to just switch between these shots. So now everything lives in context. If you're an artist and you have 5 shots to work on in a sequence, they live all in the same place. They all live together in one place. If you need to say, oh, you know what, when this building topples over and there's this dust cloud in shot 1, it would be really nice if it lingered a little bit in shot 2, even though technically it doesn't need to be there. So I'm going to retime that, bring it into shot 2, include it just for a couple of frames in shot 2. So it opens up the artist to have the ability to grab the bits and pieces that they need. And again, because we're living in these distinct layers, you're never disturbing anything from any other layer in your scene. You can work, other artists can be pulling in these exact same shots and exact same files and working on completely different shots without ever sort of stepping over the other artist. However, you can probably anticipate a bit of a problem here because we just have this switch node at the bottom. And that's going into a file, a ROP at the end, writing out a USD file. And that's error prone immediately. As soon as you have to rely on somebody to say like, oh, I need to move, this switch has to be at value 2, but this one has to be at value 1. Imagine a much more complicated setup where you have multiple switches, bringing in different elements from many, many different places. You don't necessarily want to have somebody going through the network and changing all of those switches. So we've introduced something called a context options editor in LOPS. And this is essentially a, just want to make sure this video is actually playing. Oh, there we go. Something like a global variable editor, but again, more targeted to work like this, where I want to override parts of my network with something sensible, something that makes sense to an artist. So let's say in this case, I want to change shots where I change that switch value, but also change the name of a file. So I can say, okay, I want a menu. It's called shot. We'll just say there's shot 1, 2, 3, 4, 5. And I want to be able to access the value of this menu in my network. So I'll just go to my switch node, and instead of having a value in here, I'll just say @shot, which is the variable that we just created. And in our file name, I'll change hip file name to @shot. And in reality, you would probably want to compile multiple of these things together for the sequence name and so on. But the point is, I've got this variable now, and I can just plug it in anywhere in my scene where it's useful. And now my context options editor can be tied to a hotkey, and I say, okay, show me shot 2. And all of the settings for shot 2 are placed into my scene graph. Same thing for shot 3, shot 4, and so on. And now this is a simple example where we're just using this switch, but you can imagine this expanding throughout a template where a sequence level artist might say, okay, these are the render settings for a final render. I'll make that a context option. These are the preview settings. These are the materials that we need for this scene versus this scene. And this high-level set of tools can be imported by any artist who's working on this template. And now you have this very high-level set of controls where you've removed sort of the error-prone habit of even just a typo that might be a bit disastrous when you're writing out these large numbers of sequences. So everything we've shown you so far works on this. It's a relatively simple scene. There's only 30 assets or something in here. So we wanted to definitely show you how things look on a much more large scale scene, a more dramatic scene than this. And Disney Animation provided to the community this Moana Island data set months ago. I think it may have even been late last year. And so we took the time to take that data set and convert it into USD and then load it into LOPS. So here we're just going through the cameras that are set up from that file, and you can see how quickly you get to a level of detail that's useful. Obviously, this is a much more complicated scene. When we render this, I believe the statistic is 19 billion polygons or something crazy like that. So it's a huge production quality scene. And so even though this is going to take quite a while to render, in our tests it was about an hour-ish. In about 20 seconds or something, you actually do get something that's usable for lighting purposes, right? Now this is obviously not a final render quality, but this is enough to sort of see through the noise and understand how your lighting is working. And here's just a more interactive view where we're actually moving the camera around. Now this is an extremely heavy scene, so you can see the performance is not quite as snappy as it would be otherwise. There are ways to make this faster for interactive views, but we wanted to show you the full data set sort of live without any sort of tricks to make it render faster. And as I said, even though it's obviously this is not final render quality, this is enough to start evaluating lighting and so on. So we talked about Karma this whole time. You've seen it sort of being turned on and off and showing different aspects of what it's possible to do. And as I mentioned before, it's a CPU-based render engine. It is very flexible. We've sort of built it with a plug-in architecture, so we can put in different libraries. We can expand the capabilities. But I'm sure everybody is sort of asking, like, well, what about a GPU renderer? Like, is there a GPU renderer? And the answer is that, yes, there is a GPU version of Karma. It's not ready for release just yet, and it probably will not be, almost certainly will not be ready for the next version of Houdini. But we did want to give you a little preview of Karma running on the GPU, and you can see the nice super fast performance you would expect from something like this, where the noise resolves itself in just a couple of seconds, even on a scene with, I think, 100 of these USD kitchen scenes with the reflections and so on. So this is coming down the pipe. We are working on a GPU version of Karma that will work with LOPS as a Hydra delegate. It's not ready yet, but we wanted to show it to you because it's cool. So that is everything we have time to show you today. We've kind of just scratched the surface of the possibilities here. So thank you very much for coming out, and I hope it was good for you. I think we're going to do some Q&A if anybody has any questions. I'll do my best to answer any questions you have.
Does Karma work outside of LOPS or just inside LOPS?
So Karma ingests USD, right? So it doesn't use IFD, so it doesn't work in the way you could normally with Houdini. However, we didn't talk about it here today, but there are tools for just automatically pulling out object-level things, object-level materials directly into LOPS sort of automatically. So it doesn't technically work outside of LOPS, but you're able to import everything that you would expect into LOPS kind of in one node.
So if you're inside another context, you can use Karma, but if you bring them in. Okay.
That's right, yeah, exactly.
Hello, that looked great. I'm a lighter, and one of the first things we do is set up render layers. Mm-hmm. You didn't mention that, is there?
Yeah, we haven't gotten into that. There absolutely will be nodes for setting up things like AOVs, render layers, enabling and disabling things, setting render properties on various things. We didn't have time to cover it today, but that's, absolutely, there will be lots.
And then sort of follow up, and then once we've done that, we set up also light links?
Yes.
Linking lights
oh, yeah, absolutely, yeah. So much like the light mixer that we just showed you, but it has this custom interface, there's also a light linker interface, which again is customized for artists to just drag and drop to create light links. Again, we just didn't have enough time to show it today, but look forward to that at the launch.
And both those get put back into the USD?
That's, of course, absolutely, yeah.
So if I have a camera lens shader which does like fisheye that works in Mantra, will it work in the new Karma scene view?
That is an excellent question. I would assume it wouldn't be a direct port from the Mantra version to Karma, but Karma does use Vex, so it should be relatively trivial to make it work in both. Yeah.
Okay, thank you.
It's very hard for me to see over there.
Does it also support OSL or not?
I couldn't quite hear you, actually.
Does it also support OSL, or is it purely Vex?
I believe OSL support is planned. Currently, it's Vex right now, but we want to try and support as much of those open source things.
And have you
as
done
possible.
any work to do the VDBs that don't have to be written to disk, that can go through Hydra in memory?
That's a good question. I'm actually not sure. I'm
Okay,
sorry, I'm not
thank you.
sure about that. Yeah.
Is the idea for Karma to like replace Mantra, or is Karma just for the viewport LOPS stuff?
No, it's a full replacement for Mantra. Absolutely.
Okay.
Yeah.
Cool.
Is the Karma on basis render or basis render?
Sorry, I can't see or hear you.
Is the Karma on basis render? Is how's it compared to the Mantra?
I still can't quite hear the question, actually. So,
Is this unbiased
unbiased.
render?
I'm going to say yes.
Yeah. So how's it compared to a Mantra? Is it full function like Mantra?
That's the goal. We're working towards that goal. At the moment, they're still missing some features, but it should be the equal of everything Mantra can do, plus hopefully a lot more.
Okay.
Hi. Any plan to support Autodesk Arnold?
I heard somebody say yes, so yes. That was Kristen. He probably knows.
Does Karma support hair procedural?
We're working towards procedurals. There's a bit of ambiguity of exactly how that will work with USD, but there should be a solution for, and we've done tests, honestly, without a procedural version, and it was still quite performant. So we're certainly going down that path because everybody wants a procedural, but it's a bit of an open-ended question with USD right now.
Hello. Is there, what kind of things can you author to USD that you are planning on adding soon, I guess? Is there anything that you don't support right now, like authoring certain kinds of USD edits that you are planning on adding, or?
The plan is to support everything that USD can do, and we're pretty well along that path already because we are essentially using USD under the hood directly. So
nothing is missing?
It shouldn't be. I mean, it's hard to know at this point because we're still working on it, but hopefully nothing will be missing.
So we're gonna be able to like write out any sort of geometry file as a USD and import it back in, or how does that work? Like I can just export any sort of like volumetric simulation or?
Yeah, so like again, everything that USD supports, and that includes just referencing geometry from disk. So pretty much anything you can generate now, you should be able to use with USD. Yeah. But with the advantage of including things like, materials and so on, that become editable primitives later. So a material written into a USD file, like again, like a photogrammetry material, maybe to pull in the color information from the points or something, can live just on the primitives. So it's a really nice way to transport that kind of data.
Does the USD material assignment stuff supersede material style sheets then?
Yeah, it's meant to be a replacement for material style sheets. We're trying to get all of the same functionality, but as you could see, material style sheets were a bit obtuse in a way. They were like it was a spreadsheet, and there was a lot of sort of managing of that. We want to take all of the power that you had there and make it more of a node-based, sort of more clear way of working.
Cool. And I guess the same question for like the old light rigs and stuff like that?
It should be. I guess I'm not exactly sure what you mean by the light rigs.
Oh, how you can like export light rigs. Will that be replaced by these like light collections?
Oh, very likely. Yeah, exactly.
Okay,
yeah.
cool.
Yeah.
So I see that you're going to support Redshift and whatever. Are you going to be able to allow arbitrary Hydra delegates to access the viewport and render?
I believe that's the plan. Do we have a developer? Yeah, we have a thumbs up from the developer.
Awesome.
Questions?
How does it play with takes?
How does it play with takes?
I don't know that anybody's actually tried to do anything with takes and USD. I would assume since it's just the nodes with parameters, it probably interacts exactly as everything else does. But I have not actually tried it, to be honest with you. Ideally, you wouldn't have to use takes because everything you would want to set for your render settings will be available as nodes, essentially. But I don't see why it wouldn't work.
I think we're just about out of time.
We're good to
So
go?
thanks so much, Scott.
Okay. Thank you very much.